First question on your assessment. We got this trapezoid that we got off of page 445, part A. They just want you to draw a congruent shape to this. Congruent shape means it has to be the same size and it has to be the same shape. Now, the way it's turned, where it's at, that doesn't matter. So you could have drawn it like this if you wanted to. You could have drawn it like this if you wanted to. You could have drawn it over here if you wanted to. It doesn't matter. You could have rotated it around. You could have reflected it over something. You could have just moved it around and done a translation. It doesn't matter. As long as it's the same size and the same shape, it's congruent. Now, the other word that was similar to this is actually similar. And similar is only the same shape. Size doesn't matter. So if I just wanted to draw a similar trapezoid, I could do this. I could just draw this, 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 this. That is a similar trapezoid just because it's the same shape, but it's not the same size. If you drew something like this, depending on whether you made it like this or like this, doesn't matter as long as it's the same size and the same shape. All right, I just put a few capital letters on here and we're going to show symmetry. Symmetry just means that wherever you cut it, the one side is exactly the same as the other side. So let's start with the letter A. Now, if you didn't have these letters, you're just going to have to kind of figure out whether you're right or wrong, but I think these examples will give you enough to figure that out. So for A, if I try to slice it like this, the top's not the same as the bottom, so that wouldn't work out. But I can go like this, right down the middle, then both of my halves are the same. For B, if I try to go up to down, both sides of my B are not going to be the same. But as long as it kind of depends on how you draw your letters, but if you actually have decent handwriting and you know how to write a letter, this B should have, let's try that. That's as good as it's going to get. This B should have some symmetry. If I cut it right here, the top is going to be the same as the bottom. I could fold those over and match them up. Same thing for the C. This is going to work. Top and the bottom are the same. Now, I couldn't do it like I did the A here because these two halves are not the same. For the D, again, this one I'm going to have to go like this. Top and the bottom are now the same thing. I could not go straight down like this. Now, the H is an interesting one because I could go straight down like this and both of my sides would be the same. I could also, as long as my line going across here is right exactly kind of in the middle here, maybe I should take a little bit off my H to make sure there. I could also draw it like this because now the top and the bottom are exactly the same. The same works for I. I could cut it straight down the middle and my top and my bottom are the same. I could cut it vertically, up and down, and now this side and this side are the same. Z is an example of a letter that doesn't have any symmetry. If I try to cut it like this, it's not going to fold up and it's not going to work. If I try to cut it like this, both halves of the Z aren't going to be the same. Now if I change it like this and I make an N, it's the same kind of deal. If I cut it like this, my top and the bottom are not going to be the same. If I cut it like this side and this side are not going to be the same, so we do not have symmetry. So there are plenty of letters, plenty of figures that don't have any symmetry at all. You just got to be very careful that if you try to make a cut, like if I make a cut right there, that half would have to be the same as that half, and it isn't exactly the same because parts are on different sides. So make sure you keep that in mind when you're checking, and if you have a question on whether it is. Alright, you could have chosen any shape. I just picked a triangle and then I drew a line to reflect it over. We're going to show a reflection. So after I make my triangle, I want to label the points on the triangle or the vertices, just so I know that when I reflect it over that the right points are in the right places. Okay, I do not have a ruler with me, so I'm just going to estimate. You just have to remember that each point has to be the same distance away from the reflection line. So point A is about that far, So I'll move it down here and it's going to be that far. So I'll put my point A right there. Point B, that far. Down on the reflection line looks like about that far. And again, this is just going to be an estimate. Now, if you think about how this shape should look, it's going to be the reflected version or the mirror version. So this C is going to be all the way down here. So this is going to be a little bit more difficult, but I think we can still do it here. There and there. There would be C, A, and B. Now I have to do connect, and we have our reflected shape. Okay, it's exactly reflected over, or it's the mirror image of. Now I could have drawn this reflection line any way I wanted to. I could have drawn it like this. I could have drawn it like this. Either way, you still have to figure each point, how far it is away from the reflection line, and make it the same distance on the other side of the reflection line, and you'll be. All right, we're looking for a shape that you drew. I drew an isosceles triangle. You could have drawn whatever you wanted. And what it looks like after a clockwise turn of 270 degrees. Here's our clockwise. 270 degrees would be almost a full circle. So it's going to be almost back to the beginning. So this would be our 90 degrees. This would be our 180 degrees. And then our 270 degrees would look like this. This would be the category that you would want depending on what your shape is. You just have to remember that a full turn would be 360 degrees. 270 is just a little bit less, so it would look like this. Now, this wasn't part of the question, but the counterclockwise just goes the opposite direction. 90, 180, 270 is almost back to the start, and then 360 is all the way to the start. So when you draw these out, the answer for this question should be in this category, clockwise turn, 200. All right, for the next question, I'm just going to stick with the isosceles triangle, two sides the same, one different. This would be an example of something that only has one line of symmetry. If I try to cut it like this, horizontally, side to side, if you look at this, this part of the triangle is different than this part of the triangle. So that would not work. Okay, so that's definitely not going to work. But if I take it and go straight down the middle here, now I can see that this side of the triangle is the same as this side of the triangle. As long as you have a shape where you can only have one line of symmetry where it's the same on one side as it is on the other, and it doesn't have two or three, then you would have got this question right. All right, last question is, what is happening to these shapes? Okay, and we've got choices of translation, which is just moving it. We've got reflection, which is the mirror image, and we've got rotation, which is just turning it. Okay, so the first one is we're just moving it. Okay, we didn't rotate it, we didn't reflect it, we're just moving it. And if all you do is move it, that's a translation, or also move, or slide. Okay, we didn't do anything else, all we did was move it around. Number two is definitely a reflection. Okay, this would have been the reflection line right here, and basically we just reflected one side over the other. This point, same distance from the reflection line as this point. This point and this point, this point and this point, this point and this point. So this is definitely a reflection. Also, a reflection can be referred to as a flip. We flipped it over this line. Last, this one is definitely going to be a rotation or a turn. We rotated this shape. If this is the normal shape and this is at 0 degrees, to get to this shape right here, we could actually do a counterclockwise 90. So I'll put CC 90, a backwards clock rotation of 90 degrees or one turn, or we could have done a clockwise rotation of 1, 2, 3, which would be clockwise of 270 degrees. So that's definitely a rotation or a turn. So we've got translation, which is just moving it. We've got reflection,